Section 1.5 and 1.6. All right, we're going to be solving equations by hand, and we're also going to use the calculator. So we're going to be using the online Desmos calculator for this, and you can always use a graphing calculator, 83, 84, 86, whatever you prefer, 89. But you can also use the Desmos calculator and use the Desmos test mode app on your phone, because it will lock your phone, and you are welcome to use that on a test too. We can talk about that later. But anyway, if you want to, you can get it on your phone if you want to also practice that graphing calculator on your phone or your tablet. So again, we had said before, when we want to solve something analytically, I'm going to go ahead and number these. So given something like this, it's just an equation, solving an equation. Okay, something like that. And again, analytically means by hand, because you have to do this on your test. So right here, we want to distribute the 3 through. So we're going to have 3x, 3 times a negative 5 is a negative 15, plus 2. Now this is distributing a negative 1 through. That's pretty much what this means, negative 1. So negative 1 times x is a negative x. Negative 1 times a positive 2x would be a negative 2x. So 3x, and then here we have negative 15 plus 2 is a negative 13. And negative 1x minus 2x is a negative 3x. You need to show these steps, all right? These are what I expect to see. So you're going to need some paper. I'd highly recommend getting graphing paper if you can. You don't have to. It's just easier because we're going to, chapter 2 is all about transformations of graphs. And it's really nice if you have graphing paper for that, just to kind of throw that out there. All right, so let's get our x's on one side. Doesn't matter which side you get it on, really. We just like to have them positive if possible. Then let's get our constants on the other side. Okay. And then we just divide by this coefficient. So x is equal to 14.6. But I do want you to reduce that. You'd lose a point if you don't reduce it. So they both can be divided by 2. So that's going to be 7/3. All right, so your solution there is 7/3. So x equals 7/3. That means that's where this is going to be a solution. The x value is going to be 7/3. All right, so I'm going to show you one also that is on a graph. All right, so using, or just using a graphing utility for this one. So here we have pi. Now doing this by hand, why would this be an issue by doing it analytically? Well, we could do it by hand. We'd have to use this irrational pi and make it 3.14, right? So we'd have to estimate that, which we can. And so we're not going to get an exact answer, right? Because we have this irrational number in there. So I could really do it by hand, but would rather not if we didn't have to. So let's take a look. I'm going to share my screen here and show you how to use this Desmos calculator. Let's see where I have it. So here is the Desmos, and all you have to do is just get this here. Oops. There we go. Just go to Desmos graphing calculator, DESMOS, and it will bring you here. You can get in here. Down here is, down here is the keyboard. So what I'm going to do is I'm going to type in the left side of the equation on the left side of the equal sign. So what I have on the left side of the equal sign is I have a pi parenthesis 1 minus x. And you can type this in with your keyboard as well. So that gives me the graph of that. So I'm going to go down, I'm going to type the right side of the equation in. So that's 0.6, I'm just going to put 0.6. It's the same thing. Parenthesis 3x minus 1. And I'm going to find the point so this was the left side of the equal sign. The blue is the right side. I'm going to find what is the x value of where those cross. So the x value here is 0.757. So that would be the answer to that. X is going to equal approximately 0.757. All right, so that's where they cross, and it's the x value that we're looking for. So this is an approximation sign, the squigglies, right? These squigglies mean approximately 0.757. Just solving for x like we did up here. So that's kind of a neat way to do that. I mean, this will work on this problem as well. I could put this in for one equation, this in for the other. But if I say analytically, that means you got to solve it by hand. But you could go check that. The only problem is you're going to come out with this as a decimal. When you do it on the graph, it's not going to come out as a fraction. So you could just put this in your calculator to see what is that fraction. What is this fraction as a decimal? And that's what the x value would be. So you can check that if you want to go put that in on decimals as well. So let's do another one. Let's do another one by hand. So this one says, find the zero analytically. And we're given f of x. All right, so find the zero analytically. So that means by hand. So when it says find the zero, that means we set it equal to 0 and solve for x. All right, so we're going to set it equal to 0 and solve for x. That's what this means when it says find the zero. So this becomes 0. So I really don't want to have to worry about multiplying this fraction through and adding and subtracting. So what I'm going to do is I'm just going to multiply, and you have to do this to every single term in the equation, is I'm going to multiply by 3. Because whatever this is, that's then going to cancel that out, so I don't have a fraction there. All right, so this would become 3 times 0. And then this just becomes 1. These cancel out, so whatever my denominator, or excuse me, whatever my numerator is here is what that becomes. So these cancel. So I'm going to have 1, whatever my numerator is left. I don't mess with anything inside the parenthesis because I'm multiplying this by 1/3. So when I multiply this through, I'm multiplying it now by 1. So I don't mess with anything inside the parentheses. That's important. And then 3 times 1. Okay. So from there, if I multiply everything through by 1 in there, it doesn't change anything. So multiply by 1. Now combine like terms. So we have 4x plus 1. Now we're solving this for x. So let's subtract 1 and divide by our coefficient. X is equal to negative 1/4. Oh, sorry. There we go. X is equal to negative 1/4. So it's just solving equations. Now, so here we're given some equations on, and this is asking us to determine if the equation is an identity, a contradiction, or if it's a conditional equation. I'll get that so you can read it. Okay, so that's what this is asking. Given these equations, are they an identity, a contradiction, or a conditional equation? It's kind of a question there. So if we have something like this, okay, we want to determine. So I'm going to show you this first one. Let's go ahead and just solve it, and then I'll kind of talk about what it is, what these are after we do this. So let's go ahead and solve this by hand. So distribute this negative 2 through. Okay, just distribute this through, bring the 3 down. All right, so here combine like terms, negative 6 plus 3. Now if I subtract 4x from both sides so I can get x's on one side, that cancels out. So we're left with negative 5 equals a negative 3. Well, that is not true. Obviously, that's not true. So this is a no solution. And you can use this empty set sign if you choose. That means there's not a solution there. There's not an x value. I can't solve it for x. So what I want to do is I want to show you this on the graph so you can kind of see. what this looks like, just to get a visual of it. So here I'm going to do the left side of the equal sign, which is 4x minus 5. And then we'll do -2. And this is the right side of the equal sign. All right, so take a look at, get this down, take a look at the graph. And I can even zoom in a little bit if I want to. And what are we seeing? These lines are parallel. And that fits with there's no solution. The lines don't cross. There's no solution. So that's what this looks like. And what that is called is a contradiction, because there's no solution. So it's a contradiction. If there's no solution, the lines don't cross, it's a contradiction. All right, so let's take a look at another one here. So let's say we have 5x, this is B, 5x minus 9. Okay. So I just want to, let's go ahead and solve it. We'll do it by hand, and then we'll kind of look at it. So 5x minus 9, here we're going to distribute the 5 through. So -10, and then 5 times x. So you can probably see what's going to happen here. If I subtract 5x, then I'm left with -9 equals -9. Now this is different from the last one, because the last one, they weren't the same numbers, -5 and -3. So this is -9 equals -9. Well, this means this is all real numbers. That means all real numbers are solutions, all real numbers. And so there's a couple ways to write that. This is a symbol for all real numbers. You can write it that, or you can just say all real numbers. What that really means is every single, so let me just show you this before I say that. Let's take a look at it. So let's do the left side, which is 5x minus 9. So let's see here. 5x minus 9. And then the right side was 5. Oops, -2. All right, so, well, look what happens. When I graph that, when I graph this one, it's the blue line. When I graph the green line, well, it's the same line. So it's saying they are, all the solutions are everything, one line lies on top of the other line because they end up being the same line. So they all have the same solutions. So when I have two lines that cross, we talk about the point that they cross, the x value where they cross, that's the solution. Well, these lines lie on top of each other so that all of their solutions are the same. And because these lines go on infinitely both ways, it encompasses all the real numbers, right? So this is going up this way, this encompasses all these numbers here, and this going down here is all these numbers here. So it's every number on the number line. So how we would write that here, and what I'd want you to do is put this into interval form and say it is all numbers. Goes from -infinity to +infinity. And that's all real numbers. These all mean the same thing. Okay, but since we do interval form, I'd like you to try and remember to do the interval on that. And so that is called an identity. It's the same, it's itself. It's identity, it's itself. Same, it's the same line. And then lastly, we have this equation. So let's go ahead and solve it. Distribute. So 3 times 6, 3 times a -x. So let's get our x's on the same side. And then we're here, right? And then let's go ahead and divide by the coefficient. Now we want to simplify. We have 22 over 8, so divided by 2, we would have 11 over 4. So that's where those lines cross, the x value where those lines cross. So I have a solution there, so that's called a conditional equation. It's kind of conditional because it kind of depends what x is, so it's going to be, that's why it's conditional, but this is a conditional equation. So the contradiction, or there's no solution, they're parallel lines. A identity means they're the same line when you graph them, so it's all real numbers, negative infinity to positive infinity. And then if we have lines that cross, it's a solution. So that has one solution, and that's a conditional. So I should show you the graph of that as well. So here, 5x minus 4. And then the second, the right side. So I want you to keep in mind, if I don't ask you to solve it analytically, you can do this. You can just take a look at it and be able to find the solution. So there it is. The solution is the x value, 2.75. And that's the same thing as 11/4. All right. So let's get off of that. Okay, so let's move on. So now we're going to solve something analytically, and it's an inequality. So here we have an inequality. An inequality just means we have a greater than equal to sign. Okay, so here is an inequality. So the only thing we need to be aware of on this, and I guess I'll tell you this in just a second, is let's go ahead and simplify this almost as if this is just an equal sign. So here we're going to distribute, right? So 3x. Okay. So 2x plus 3x is 5x. Let's get our x's on one side. And then constants on the other. Divide by 7. X is less than, oops, can't see me, can you? X is less than a negative 5/7. Now the only thing remember, and maybe you don't remember, but when if this happened to be a -7, oops, I didn't mean to make that mark, but if this happened to be a -7 and I divided by a negative, I'd have to flip my inequality sign. All right, so anytime your coefficient, which is your number in front of your x value, is negative, and I'm solving, I'm at this last step, when I divide, then I have to flip the sign. Now I'm not saying like this, when I just subtract 6, that's different. It's when I divide by a negative. When you multiply or divide through by negative, you have to flip your inequality. But since I didn't, that was positive, I didn't have to do that. Okay, so when I asked, I want you to write that solution then in interval notation. So if you think about it, if you don't really remember, here's negative 5/7, here's 0. And you don't have to do this part. This is just a visual. So always read from the variable, x is less than negative 5/7. Well, here's negative 5/7. It does not have an equal to, so we use a parenthesis. Less than goes to the left. So if I write that as an interval, my interval starts over here, right? So this goes all the way to negative infinity. So that's where I start, as I go to negative infinity, which requires a parenthesis because you can never equal it. And it goes all the way and it ends here at negative 5/7. And because it didn't have an equal sign, we use a parenthesis, and that's the interval notation for that. All right, so now we're going to solve an inequality that has actually, it's kind of two in one. So here, and I'll tell you what, this problem, similar to this, is on your final. Just giving you that heads up. I remember seeing it on your final. So here's the problem. So really, it's two problems in one. So when I used to teach this to younger kids, or in high school even, I would just do two problems. I'd write this problem, and then I would write this problem and get the two solutions that way. But it's a lot quicker, and it's a lot easier to do it as one problem. The only thing you have to remember here is whatever I do on this side, I have to do on this side. I have to do it to both sides. Okay, so if I'm going to solve for x, I need to get rid of the 1. So all I do is subtract 1, but I have to subtract it from here, and I have to subtract it from here. So this becomes a -6. Now I'm at negative 2x, and this is a 5. So that's not difficult, right? Just getting rid of the constant. So just like solving an equation, what would I do here? I would divide by whatever's in front of x. Now remember what I just said though. If I have inequalities and I divide by a negative, I have to flip these signs. So -6 divided by -2 is a +3. I'm going to flip that This is x. And then I also have to flip this one. And this is a negative 5/2, right? Because this is a positive divided by negative, so it just remains a negative. So you have to flip the signs. And that's it. That's all. And now you have to just put it in interval notation. And maybe we want to look at it. If you can do it without this, totally fine. Negative 5/2, 0, 3. So read from x. X is less than or equal to 3. So it's less than. So it's going this way. That's why we read from x. And it's a bracket because of the equal sign. And then here we have x is greater than negative 5/3. It doesn't have an equal sign, so it's a parenthesis, and it's greater than. So this is where all of our solutions lie. So let's write that as an interval. We start with a parenthesis, negative 5/2. It goes to 3 with a bracket. And that's the answer as an interval. Okay, I wanted to ask, let's see here. I want to go back. Okay, so we good with that? That's our inequalities. I want to talk a little bit about, I'm going to go back to Desmos here and take a look at this graph that we have. All right, so keep in mind the purple is this one, right? And then the second equation is this one. So let's just say these are two different functions. All right, so I'm going to say that the purple is f of x and the black is g of x, just so I have different. So I want to know, when is this f of x less than g of x? So when is this line, the purple line, less than the black line? Well, it's when it falls below it. So if I look here, this is where it falls below the black line. So I'm going to write this on the paper and I'll show it to you. So the question is, when is f of x less than g of x? So this is the purple, this is f of x, this is g of x. Well, it's from here to here. So what I do is I look at what is the x value here. So would you agree that this is going to go out, keep going all the way to negative infinity? We're looking at our x values. This goes all the way to negative infinity. So I'm going to write this as an interval. This is less than this when we start at negative infinity. And it goes all the way to here, and that's when it stops being less than. So what's the x value there? 2.75. And we keep that as a parenthesis because the line 2.75 is not less than. It's on the line, so it isn't less than, so we keep it a parenthesis. So here is how I would write that. When is f of x less than g of x? Well, from negative infinity to 2.75. So when is then, could you tell me, how about when is, let's go with g of x, the black line, when is it greater than f of x? So when is g of x greater than f of x? So it's from here. So it's greater. Now again, we're looking at our x values. So this keeps going this way, it keeps going to negative, right? Keeps going to negative. So negative infinity to 2.75. Same answer. What if I ask, when is f of x, which is the purple, when is this greater than g of x? So when is this line greater than this line? Well, it's greater when it's above it. So here, from 2.75 with a parenthesis, now this keeps going this way, which is positive infinity. These numbers keep getting bigger as this goes. So from 2.75 to positive infinity. All right. So let's move on and talk a little bit about, let's do a similar triangle. I'm going to do a couple application problems. So let's say we have a tree. I'm just going to draw a normal. All right, so here's our tree right here. Okay, that's our tree. And it casts a 27-foot shadow. So this whole length here is 27 feet. I'll just put a, okay. And then a 6-foot person. So we have this person here. Okay, we have a person. If you want to draw out a person, we'll make it a girl. who is 6 feet, so we know that she's 6 feet tall. And she casts a shadow that is 4 feet. Well, here's her shadow. So from here to here is 4 feet. The question then is, well, how tall is the tree? How tall is our tree going to be there? So what we want to do is set up similar triangles. And the only thing we have to do is be sure we're doing like side. So if we want to do like this to this, then we do the same thing, this for the little triangle. So notice we have two triangles. We have a big one and we have a little one. So let's set it up as a proportion. Let's take the height of the tree. The height over the shadow is x over 27 for the big triangle. And then for the person, it's going to be the height over the shadow. So they're both height over shadow, height over shadow. And then we're just going to cross multiply that. So we take this times this, 4 times x is equal to 27 times 6. And then we solve that. So x is 40.5 feet. That's how tall the tree would be. So that's just setting up a proportion using similar triangles. All right, last problem. Oh, okay, I've got two more. Two more, hang in there. All right, here we go. So a student's planning to produce and sell music DVDs. All right, so the DVDs is gonna sell the DVDs for $5.40 each. Okay, that's how much he's gonna sell them for. A computer with a DVD burner. So the computer costs $800 to buy. And then the blank DVDs that he would burn them onto are 40 cents a piece. So the question I'd like you to find is find a formula. Find a formula for a function. We'll call it R. I'm just giving you that because it calculates the revenue. Okay, so it calculates the revenue. So revenue is how much money that he has to pay. The student is planning to produce and sell music DVDs for $5.40 each. So how's he going to make his money? Well, he's going to make it with this. So his revenue, let's just write it as a function, is going to be $5.40 for every DVD that he sells. So that's the money he's going to make. That's revenue. So then calculate the cost of recording the discs. All right, so what is going to be the cost of recording the discs? Well, don't forget you have to buy the computer for that as well. So the discs are going to be 40 cents a piece. So however many we buy, we'll just put an X there depending on how many we need to buy. Plus the computer is going to cost $800. So this cost is what it's going to cost them, the student. But then this is the amount of money that student would make. So the question is, what is the break-even point when he can begin to make a profit? So what is the break-even point? Because once he passes that, or she, then they can start making a profit. So how I find that is just what we did on Desmos, is I set Rx equal to C of X. Whoop. Rx equals C of X. So let's do that. Let's go ahead, and we could do it by hand. We could just take, this is what we're doing. We're taking 5.40x. I think I am just going to do it by hand. It's a lot easier, I think, than typing it in. But you could put it onto Desmos and do it that way too. So we're just going to subtract. So this is just 5x equals 800. So we divide by 5. X is going to equal 160. So that means 160 discs. He needs to sell 160 discs, not desks, discs, to break even to where he starts making a profit. So anything more than 160 discs, he'll begin making money. And this is really, I mean, important. And we do this a lot in real life with our business you know, setting up when we're going to make a profit and what that's going to cost us and so forth. So it all just deals with these linear equations. All right, so kind of cool, break-even point. All right, last problem. I got to find some room up here at the top. I'm running out of paper. All right, so volume is equal to pi r squared h. That's the formula for volume of a cylinder. Nope, it's not a cylinder. That's just, yep, it's a cylinder. Pi r squared. So what I want you to do is I want you to take this and solve it for h. So what we're doing is just taking a formula and solving it for a variable in that formula. So if I want to get h by itself, these are all, this is saying this times this times this. So I can just divide by pi r squared, but then I divide this also by pi r squared. So the volume over pi r squared is equal to h. And that's it, just solving for the variable h. All right. Well, thanks for listening. Hope this helps, and I hope you guys have a great day.